Hi guys, it's Mrs. Glenn. Welcome to the 6.4 using Vertex Form video. In this video, you're going to learn how to use the Vertex Form to identify key features in quadratic equations and on quadratic lines or parabolas on a graph. So refresh, we have Vertex Form is y equals a parentheses x minus h quantity squared plus k, where h and k is the vertex. Remember, h is the x value after you use the formula x equals negative b over 2a. And then you plug that answer back in and solve for y, and the y answer is your k. All right, so let's take a look at a problem. So we have y equals x plus 6 quantity squared minus 4. So first thing you have to do is remember the vertex form. So we have y equals a times quantity x minus h squared plus k. So now we can identify the h and the k. So this is plus 6, which means that h must be a negative 6. And that's a minus 4, so that means the k is a negative 4. So your vertex would be negative 6 comma negative 4, because remember, h and k are x and y. Then to identify the y-intercept, remember the opposite letter is 0. So if we're looking for the y-intercept, the x-intercept will be 0. So all you have to do is plug 0 into x and solve for y, and you'll get your y-intercept. So we're plugging 0 in wherever x is in the original question. So then we replace that, and now we're just going to use order of operations to solve for y. So 0 plus 6 is 6, and then you get 6 squared minus 4, which turns into 36 minus 4, so y equals 32. So then that means the y-intercept is 0 comma 32. So for your x-intercepts, remember we replace the opposite letter with 0. So instead of writing y, we're going to write 0. Or you could factor if you're able to factor the problem. So in this situation, we're going to plug 0 into y. So then we solve for x. So we're going to add 4 to both sides first. Then you're going to get 4 equals the quantity x plus 6 squared. Then in order to get rid of that square, you do the opposite of squaring something, which is taking the square root of it. So if you take the square root of both sides, remember, we get a plus and a minus answer for the 4. So that means we'll have plus or minus 2. So that means you have to solve both questions. So you have to solve it if it was positive 2 equals x plus 6, and then you have to solve it if it was negative 2 equals x plus 6. So we subtract 6 on both sides, and you get x equals negative 4. Then for the negative 2 one, we would subtract 6 on both sides and get x as negative 8. So your two x-intercepts would be negative 4, 0, and negative 8, 0, because the y's need to be 0 in order for them to be x-intercepts. All right, so for D and E, we have to graph the function. So I'm just going to bring over the information from A, B, and C, which are vertex, y-intercept, and x-intercepts. So the y-intercept is not going to fit on this graph because 32 is too big. So we're going to just worry about the vertex and the x-intercepts. So I've already drawn the vertex here on the graph. So now you do your two x-intercepts. And then you're just going to make your parabola. So this parabola is pointing upwards because we don't have a negative a value. And it looks like that. And then you're going to put your axis of symmetry down the middle. And remember, we need to have it at a dashed line. So your axis of symmetry would be x equals negative 6. Okay, so for this one, to find the vertex, we're going to remember the vertex form. So that is y equals a times parentheses x minus h quantity squared plus k. So that means h is negative 1. H is positive 1 because that's part of the formula x minus h. So h has to be positive 1. And also k would be positive 2 because it has plus 2. So now that means that our vertex is 1, 2 because x is h and k is y. Then we're going to find the y-intercept by plugging 0 in for x. So we replace x with 0, and we're going to 0 minus 1 is negative 1. And then you square negative 1, which is negative 1 times negative 1, which is positive 1. So 3 times 1 is 3, and 3 plus 2 is 5. So our y-intercept is 0, 5. For your x-intercept, same thing as before, plug 0 into y. So then we're going to subtract 2 first, then we're going to divide by 3 to get our parentheses by itself. Now you have to take the square root of both sides to get that square off the parentheses. And if you notice something, we can't take the square root of a negative number right there. So that means there are no real roots. All right, so for the last part of this problem, we have to draw the axis of symmetry and graph the function. So I'm going to bring over the things from the ABC, which is the vertex is 1, 2. The intercept is 0, 5, and we don't have any x-intercepts that are real roots. So let's plot the 1, 2 and the 0, 5. And we don't have a third point to be able to graph the rest of our parabola. However, we do know that the axis of symmetry goes down the vertex. So the axis of symmetry makes that parabola symmetric. So we can put another point on the other side to the right of it, right where that y-intercept is, but just to the right of the axis of symmetry. So watch the graph. So there's our other point. So now we can actually make our parabola, and that's what our parabola is going to look like. And that's why there are no x-intercepts, because if you can see, the parabola never crosses the x-axis. Go Seahawks. Woo!